We're going to talk about the properties of real numbers, and here we're going to talk about what you can do with numbers in terms of their grouping, their order, and things of that sort. And so we have these basic 5 properties that perhaps you don't need to remember their names so much, you just have to remember what they do. And so the commutative property says that you can turn around the order of addition. Okay, so you have 5 plus 3 equals 3 plus 5. That may seem almost trivial, but it's not. It is actually has some meaning. And then the commutative property of multiplication, AB equals BA, I should be saying. Okay, and so that would give us 5 times 3 is 3 times 5. Now, odd as it may seem, there are some forms of multiplication that are not commutative. So when you're dealing with matrices and things like that, they're not commutative. But we're dealing with real numbers, and there is a commutative property of multiplication. So the associative property of addition says that we can add in any order. Now this is a little different than the order of operations, right? The order of operations say we add right to left. This particular property says it doesn't matter so much with addition. So we can take 1 plus 2 plus 3, do the 1 plus 2 first, or we can add the 2 and 3 first and then add the 1. So we'll get exactly the same thing. Now with addition, remember that equivalency between negative numbers and positive numbers. So long as you put your negative numbers in parentheses and the negative number rides along with that, with the negative sign rides along with the number, you're going to be fine here. Now there's also an associative property of multiplication. So you can take 2 times 3 times 4 is the same thing as 2 times 3 times 4. Now this will be true for all of multiplication, but it's not true for division, because remember we have division defined as multiplication by the reciprocal. And so if you make division into multiplication of the reciprocal, then this will work. Okay, but be very careful when you're using the associative property of multiplication. When you have division in there, make very certain that you have your quotients or your ratios represented correctly. And then we have the distributive property of multiplication over addition. This basically says if you have a grouping of addition, you can distribute the factor in front of it. So if you have 3 times the quantity 2 plus 5, that's the same thing as saying 3 times 2 plus 3 times 5. And it works the other way around too, where if you have a quantity 2 plus 3 times 5, that distributes as well. So it doesn't have to be, the multiplication doesn't have to be in front of the parentheses. It's just that the multiplication has to be outside of the parentheses, the addition has to be inside the parentheses. Okay, so now we have identities and inverses of real numbers. The additive identity property for, for addition, the identity property for addition is a plus 0 is the same thing as 0 plus a, which is just a. So you can always add 0, and you get your original number, like 4 plus 0 is 4. That may seem trivial, but we'll find sometimes that it's convenient to add a 0 if we represent 0 as something like 2 minus 2, which is 0. So we can say 4 plus 2 minus 2 equals 6 minus 2. So there's some operations that we can do in here that may make this property a little bit more useful than it seems. The identity for multiplication is a 1, so we can multiply anything by a 1, or multiply 1 by anything, and we get that number back. So 4 times 1 is the same thing as 1 times 4. Monday I talked about the additive inverse. So we have this negative quantity, so a plus a negative a is 0. Take any number in there, 4 plus a negative 4, and that equals 0 as well. And lastly, the multiplicative inverse says that if we take a times 1 over a, we should get 1. The one exception to that is when a equals 0. Now, occasionally you'll see these things in a magazine or in the paper or something like that, maybe some sites on the internet where they kind of prove that 2 equals 0 or things of that sort. Maybe you've seen some of these. Almost all of them rely on the fact that they are violating this principle that you can't divide by 0. And so once you're dividing by 0, all bets are off. You're not making any kind of equality anymore. Your equations don't have any meaning. So now here we have some properties that will help us simplify things. So if we have two numbers that are equal, then we can add anything to both sides, or we can multiply anything to both sides and end up with the equality. The same thing is true for the other direction. If we have x plus 2 equals y plus 2, then x equals y. All right? So in other words, you can add or subtract anything from either side. You can multiply anything to both sides of the equation, and we get an equivalence. The one difference is, in this rule, is that if AC equals BC, C cannot be 0. It would be true, 3 times 0 is the same, equals 4 times 0. That would be a true statement, but that doesn't mean that 3 equals 4. So whenever you have this quantity C that you're multiplying on both sides, you have to make sure that it's not equal to 0 to conclude that the other factor in there, the A equals B. Okay, so if 2y equals 2x, y equals x. It's just that simple. I've already talked about most of these, the properties of 0. A times, or 0 times anything is 0. 0 divided by anything is 0, so long as you're not dividing by 0, because A divided by 0, any number divided by 0, is undefined. This is going to be a really useful property in later on when we're dealing with polynomials. When we're trying to solve polynomials, if we're looking for where does this polynomial equal 0, if we factor it, then one of the factors has to be 0 in order for it to be 0. And then we have the negation properties, that -1 times A is the same thing as -A. -1 times -A equals A. And then we have -A times B is the same thing as A times -B, which is the same thing as -AB. -A times -B equals AB. Notice the negatives go away because we're taking two negatives that make a positive. And then there's 3 ways to represent a negative ratio. You can put the negative on the numerator, you can put the negative in the denominator, or you can put the negative out front. And in fact, you can move these around if you're simplifying expressions anywhere you want. So if you have a convenient expression in the denominator, if you take the negative denominator, then you're perfectly free in doing that so long as you change the sign of the numerator. And generally when we simplify things, we put the negative out front so it's standing out by itself. So those are your properties. That's section 1.3. We're going to be making use of a lot of these. A lot of these look trivial, and then once we take them in a little bit more complicated circumstance, they turn out to be very helpful. But basically, it's one of those things that for simple equations, they apply very readily. For more complex situations, they're remarkably useful.